right, so I'm making this video early, but it shouldn't take too long. What is the exact value of arc sine 1/2? So we have some options here. If we're using the unit circle and not our calculators, then let me pull it up. If you wonder why ooh, it's this one. That's cool. Does it give me all of them? No. Let's do it in radians. What in the world? Oh, okay. Let's just search it then. I do this so you see that whatever information you need, it's out here. Well, that's terrible resolution. It might take a couple clicks, but here we go. Let's go back over here. We're online anyway because we're taking this quiz. So what is the exact value or the value of arc sine 1/2? Well, I look for 1/2, but right here. This, because remember the sine and the cosine for the x coordinates on a unit circle, it doesn't work when you don't have a radius of 1. Cosine theta, sine theta. Uh-oh, I'm about to go off on a tangent. Right, is the x and the y, or in our course, it's the a and the b values. Notice why this happens. When we set up our imaginary triangle and radius, right, if this was our circle over here and this was the x and the y, when the radius is 1, in our lesson 707, we had this idea that the cosine of theta was equal to a, the x value, over r, the value of the radians, right? So the value of, this is a or x, however you want to think of it. But if r is equal to 1, notice how cosine theta will be just a over 1. So it will equal just the a or the x coordinate. So that's how come the unit circle is so useful. Oops. So useful to us because the radius is 1. And in any case, if the radius isn't 1, we have this ratio of our imaginary right triangle. So ka toa, and the a isn't because of adjacent. The a is because it is what they call the length of this side, which on a coordinate plane, the XY plane or the coordinate grid, is the horizontal length, which is the x distance, the a, right. Anyway, let's go back to the thing at hand. So the inverse function of sine gives us, if we take the point or the value 1/2, it tells us what the angle is. So it's 30 degrees or pi over 6. Let's go see if we're right. Whew, we did it. What is the value of the arc sine of root 3 over 2? Well, root 3 over 2, 120 degrees, or 2 pi over 2. Do you see this? Root 3 over 2, the sine value. Arc sine asks for the angle, in this case radians, that we're looking for. Oh, no. Oh, this is where the domain comes into issue. 2 pi over 3 isn't in the domain of the arc sine, the inverse sine. So we have to go over here. Is that right? 3 pi, did I look at the right one? Root 3 over 2, yes. Root 3 over 2 is over here. This was too far. This was outside the domain. So we were looking for just this half of the unit circle for sine. If we were talking about cosine, we would be looking for this half of the unit circle for cosine. Okay, so now that helps us realize it's pi over 3 or 60 degrees, not 2 pi over 3. Notice how they have the same sign. There's a lot of angles that will have the same sign, the same ratio. So pi over 3. Look, it's not even an answer. That's great. So if you got confused and you found 2 pi over 3, it's not even an option. So then go back and think, wait a minute, there's root 3 over 2, root 3 over 2. There it is. Here we go. Arc sine, inverse sine, root 2 over 2. Now we know. We're not looking over here, so we have to look over here. Here's root 2 over 2. Do you see it? Root 2 over 2, pi over 4, 45 degrees. Pi over 4. Question 2, variation 2, arc sine of 0 in degrees. Arc sine of negative 1/2 in degrees. Let's use a calculator. Okay, it's all in degrees. You can use the unit circle, but I want to use the calculator. Negative 1/2, find negative 1/2. It has to be down here. But we want to go this direction, so it's not going to be 330. It's going to be, let's go look. Let's go use a calculator, okay? I want to use a calculator for these ones, so here we go. I'm just going to Google it because I know every student has access to this. I want it to be in degrees. I hit inverse sine of negative 1 divided by 2. 2 is negative 1/2. Negative 30 degrees. Let's see. Perfect. Let's look at question 2. Let's do it of 0. So inverse, arc sine, 0, we're in degrees. 0? What? Let's go look. 0, 0, 0. Look, here's the 0, here, 0. Yeah, it's 0. Cool. Arc sine of root 3 over 2, we're in degrees. Inverse, arc sine, square root of 3. I got to close this parenthesis. If I don't, when I type this division by 2, it will mess it up. It'll be inside here instead of outside, so like a fraction, 60 degrees. Root 3 over 2, we just did that. There it is. Let's keep going. Oops. Arc cosine in radians. So we can look at our unit circle, but remember, our unit circle for a cosine, we're going to look domain range, restricting the domain, restricting the range. That helps us figure out where we're looking. You can still use a calculator, but in radians, you're going to get a messy angle. But you could use a calculator and then use the unit circle to find the matching one. So let's do that first, actually. I'm going to use arc cosine of root 3 over 2. Inverse cosine, arc cosine, square root of 3, close the parentheses, over or divided by 2, because the fraction bar means division, close parentheses, we're in degrees. Cool, it's 30 degrees. Now I can go back to my unit circle, look for 30 degrees and say, okay, here it is, it's pi over 6. We did it! Arc cosine negative 1 in radians. Let's just look at the unit circle for a second. Do you see how it's over here, all the way over here? So in radians, it's going to be pi. And if we use a calculator, we're going to get 180 degrees. Let's go use the calculator just so we can practice that again. Inverse, arc cosine negative 1. Boom, 180 degrees is pi, because 2 pi is the whole circle around, and a whole circle around is 2 times 180, which is 360. Okay, cool, pi in radians, right? 180. Arc cosine of negative 1/2, inverse cosine negative 0.5. Are you okay with that? This is the decimal representation of negative 1/2. 120 degrees, 2 pi over 3. That makes sense to me. Look, here's the cosine of negative 1/2. 2 pi over 3, 2 pi over 3. Here we go to word problems. Oh man. This one is definitions, notation, how to write things. Remember, we want to solve for theta. So if we're given whatever we're getting, sine of theta is equal to x over 10, then to solve for theta will equal arc sine or sine inverse, I'll write that too, of x over 10. That makes sense. We've been doing this. We don't know what x is. Okay, so I don't know what x is, but if they told me x, I could substitute it in here. Like what if x was 5? We've been doing that. We can know that that would be, it would be 30 degrees if x equaled 5. The theta angle would be 30 degrees. This one, they're just asking you notation. How do we write this notationally? Well, if it's the inverse of sine, we take arc sine of this whole mess. If we don't know what x is, then we leave it x. But if we did know what x is, then it would be a real number, like 7/10 or 5/10, which is 1/2. Arc sine of x over 10. Not arc cosine, not sine, not cosine. Okay, because we're solving for theta, and that's our point. So we're looking for this idea that if I take the arc sine of the sine of theta, some angle, and you have to do it to both sides, arc sine of x over 4, this is the inverse of this, so we get theta all by itself. Theta equals the arc sine of x over 4. We can also write this as the sine inverse 1, x over 4. Okay, and that's all we're doing. Sometimes x equals 1, sine of 1/4. Sometimes x will equal 2, sine of 1/2 again. Okay, let me look at the last one. Hopefully it's cosine. Yay, it's cosine. Well, if we're doing this, if sine theta equals x over 4, and this is arc sine x over 4, wouldn't it make sense that this would just be arc cosine of x over 6? Yes, the same strategy applies. We're taking the inverse function to solve for the angle, right? We're getting angles. This is 120 degrees, which is 2 pi over 3 radians. So we're finding the measure of the angle. Different units like Fahrenheit and Celsius, but you've got this. Now we get to our word problem, right? We gotta use this for something. Ooh. A bird watcher. Oh, it's so pretty. A lovely bird, right? 45 feet from the base of the tree spots an oriole. What's an oriole? I'm gonna Google that. At the top of a 140-foot tree, this beautiful tree, we've spotted a bird. A bird. It's 140 feet. What am I going to draw? What do you think I'm going to end up drawing? If you said triangle, you win. A little person. Hello, bird. 45 feet away. Draw pictures. This makes a right angle. Even though trees aren't perfectly straight up and down, that's a right angle. What do you think they're going to ask me? The distance? Or the angle? We know the height. We know how far away you are. Not vertically this. Okay. Let's keep scrolling. What is the angle of elevation from the bird watcher to the oriole? Look that up. Oh, look how pretty. How do you pronounce that though? Oh, yeah, my location. Ariel. Oh, Oriole. I was right. Okay. That sounds like. Okay. Well, 45 feet from the base. What is the angle of elevation? So now we have to talk about these words. The angle of elevation, if I'm standing here, would be the angle up, right? The angle of elevation. If I were standing up here, like on top of a building, and it said the angle of depression, yeah, declination? No. The angle of depression. Mrs. Reynolds, what? I have to review too. I have to remember this stuff. There's so much we've gone over, so I understand. It's okay to not have it all on the tip of your head, your tongue, and your mind, but it's not okay to just give up and be like, I don't know it, so I'm never going to know it. That's not true. We can look it up. It's the angle of depression. So do you notice how this angle of depression, say that was like 30 degrees if you were standing on top of a building, but you needed to find this angle of your little triangle, then this would be 90 minus 60, right? This is 60 degrees. If you were going to use the relationship in this triangle, there's an invisible triangle over here you could try to create, but sometimes it's easier. Those supplementary angles, no, complementary angles. The way I always remembered it was complementary added to 90. I got to go to our help session. So you're like, what? Just solve this question. No. Added to 90 and a comp corner, unless I've got it backwards again. Supplementary added to 180. That's what I thought, and I have to double check it. But double check it. Get it in your mind. And if you forget, look it up. Use your notes. Check, guess, and check. We need to draw this picture. You're going to be given a ratio. So I'll solve just this one. Your pictures are all going to be different. Standing on a roof, angle of depression. See? Okay, angle of depression, but we got to change it up. See? Oops, top of, all right, well, we already saw this top of a lighthouse. What is the angle of depression from the top of the lighthouse? Let me pause the video, and I'll be right back. Okay, I'm back. I know I didn't pause for you, it just glitches out. But what I want to do here is draw this picture. So Jennifer stands 80 feet above sea level at a lighthouse. Very cool. I went to a lighthouse. They use something called a Fresnel lens, which, gosh, I was trying to draw the pattern. There's a great pattern so that the light gets bounced back to focus. It's very neat. So we have our lighthouse. We have the spiral stairs. We're at the top of it. So I'm just going to kind of make it more square so I can draw on the top. She stands 80 feet above, so 80 feet. She sees a boat sailing 400 feet from the lighthouse, so 400 feet away. We have our little sailboat. It's a beautiful sailboat. There's a right triangle. We made up a right triangle, but this works. What is the angle of depression from the top of the lighthouse to the boat? The angle of depression from the top of the lighthouse to the boat. Oh, cool. Okay. Top of the lighthouse down to the boat. So either it's 11 or 79, right? And we have this answer. I wouldn't know that without doing the math first. But I want you to think about this because this is one of the things that it takes, we have to ask ourselves. We're going to use tangent because we don't have the hypotenuse. Okay? We're definitely going to use the opposite over adjacent. So you're going to do arctan of 400 over 80. See what happens here, okay?